The Paperfuge, a blood centrifuge made of paper, is a groundbreaking device that can separate the contents of biological samples to diagnose illnesses that affect much of the world's population. In the 21st century, many of us engineers get caught thinking about designing for our highly technical lives. However, there are many people in underserved populations that don't experience the luxury of the developed world. Professor Prakash, the inventor of the Paperfuge, states,
So to me, frugal science is really designing with constraints in mind.
The Paperfuge is based off the idea of the childhood toy called the Whirligig. Although based off a child's toy, it can separate malaria parasites in a matter of minutes. The Paperfuge is built from 20 cents of paper, twine, and plastic. It can spin at 125,000 RPM and exert centrifugal forces of 30,000 Gs. The cheap centrifuge is capable of detecting malaria, African sleeping sickness, HIV, and tuberculosis.
When the two ends of the strings are pulled using the handles, the disc rotates. Every time the handles are pulled, the direction of the spin changes. The tool converts linear motion into rotational motion. Supercoiling occurs when the already coiled string coils into a larger coil. This phenomenon allows the Paperfuge to spin at very high speeds. Mechanical engineers will be critical in determining if the system will generate the needed amount of rotations per minute for the contents of the samples to separate. Biomedical engineers will be able to interpret the results from the system. For instance, seeing if the red blood cells separated from the plasma in the blood.
The application of the Paperfuge is far from over. Paperfuges need to be distributed to millions of people who need to get their blood tested for life-threatening diseases. People need to be willing to distribute this technology to areas in need. We can create better techniques for diagnosing blood-borne pathogens using these simple tools. The success of Paperfuge has motivated other companies to follow suit, incorporating a more frugal approach to engineering for less developed communities. Manu Prakash says it best.
By boxing ourselves in with constraints, we can think outside the box.